Advent of Code in F-star. Today is day 12. So I'll be using F-star, a dependently typed functional programming language, to solve today's Advent of Code problem. We've got a few minutes before it drops. So I'll send out a Twitter notification that the stream started. So there's something a little different about my screen here. Our designers gave me an ASCII art Akita in the bottom right-hand corner, so we can match the Advent of Code themed Santa hat on the left, and I think they did a great job. I wanted to show something else that I think is a great job. Let me switch over the screen share. So here's somebody who animated the octopi from last night's solution. So nice animated GIF in their tweet. So we got about a minute and a half left. You can learn more about F-star at fstarlang.org, fstar-lang, or on Git. It's hosted on GitHub. It's an open source project on github.com, fstarlang fstar. The reason I like F-star is it lets us prove things about our program execution by writing appropriate types or lemmas. Unfortunately, I haven't been able to prove everything that I would like to. We're having some difficulty that um, I didn't manage to figure that out. I didn't manage to spend a lot of time on it since the stream, but I suspect it's an aliasing problem, like the problems I was having with the sub problem earlier. But I don't really understand why, and haven't been able to explore that hypothesis yet. So looks like we're all set. Okay, so we have a graph of connected caves. Okay, your goal is to find the number of distinct paths that start at start and end at end and don't visit small caves more than once. There are two types of caves, big caves written in uppercase and small caves written in lowercase. Okay, so we've got to count the number of paths. And I imagine our input's not too bad. Okay. In fact, our input's so small, I'm not going to bother writing parsing today. I'm just going to copy it in, and we'll plunge it into shape. How do we want to do this? Let's do it as pairs of strings. Okay, so what do I want to replace? Whoops, did the wrong character. So hug up ops to all those struggling with the log4j vulnerability. That's been kind of amazing, not in a good way. I'm not doing this very well. I'm not sure whether I'm going to need to parenthesize all these. Let's see if we do. Oops. No, all right, good. That's our parsing, and let's get the example in there too. I think we have two examples today, as a matter of fact. So start and end are bolded because they are keywords in F-star that hold a block of statements. I generally don't use those because they're just syntactic sugar for open parenthesis and close parentheses. So I just use that. So how are we going to solve this? It seems like there's got to be a better way to enumerate them than count them all. Than better way to count how many there are than just enumerating them all one at a time. If worst comes to worst, we can do that, but I'm worried that the number may get large. And so I'm not proud. Let's look for a Wikipedia entry. So yeah, we don't want to do backtracking. No, we could do better than that, can't we? Is our graph directed or it's undirected? Well, I'm not seeing anything obvious. Yeah, that like calculating the adjacency matrix and raising it to a power gives you all walks, but not paths that obey the restriction. And the restriction is these capital letter ones can be visited multiple times, but the small letters can only be visited once. So I'm not coming up with a clever idea. So I think we're just gonna have to brute force it. All right. So one problem is we're given these pairs, but we can go in other directions. So we need to let's so we could parse that to a map. I don't entirely trust SR's maps, but it's no worse than looking things up one at a time. So let's use it. So let's write a function that takes our input format and creates a map. So this takes returns a map. What? I don't remember what the type is called. The library is not very consistent. It's map.t. Which we could just write as t, but to reduce confusion, I'll call it map.t from string to a list of strings. All right. So what we're going to do is we're going to oh, okay. We'll write this the simple way. We're going to make it a recursive function. And so we recurse on the list like usual. So if it's an empty list, then we want an empty map, which I figured out how to do the other day, but I don't remember what it was. I think it was that we have to create the constant map and then restrict it to the empty set. Yeah. So I think there's actually a reason why this works this way, because the map is a function from key to value, and there's no way to say, here's an empty example of that function. There's no way to write that. Whereas we can take something that is a well-defined function, just say, well, restrict it to the empty set. All right, so we'll take const, just shouldn't matter, and then restrict that to set.empty. Oops. Need to reload our dependencies. Oh, and it's fussy because we didn't finish writing that. That's I think my number one annoyance is when we have to reload. Oh, there we go. When we have to reload the F star state, we can't do that incrementally. It complains if there's a syntax file anywhere in it, a syntax error anywhere in the file, and I don't really get why. All right. So empty list corresponds to an empty map. Otherwise, what we want to do is take our pair. So we got a source target pair, and we want to update both directions. So update. So I haven't explained about my documentation for a while. If you go on the F star site, no, this isn't where it is. Oh, the github.oi page. It has library documentation, but most of these are empty. They're generated with an old version of the documentation tool. And so I reran everything locally, and I've got a PR out, but I don't expect it'll be accepted because I didn't check in all the changes I made to the documentation generator either. And it's, a big pile of HTML. Who knows what I put in there? All right, so update the map. All right, so we recursively create the adjacency map on the tail, and then we update the map with S. Oh no, okay. So we need to append onto the end of it. So let's write the function that does that. So we're going to take our map type and key and a value, and we're going to return the new map. Okay, and what we're going to do is we're going to say if an easier way to do this, I don't see it. So if if the key is already in the map, then we want to update it with our new value constant to the old value. Otherwise, we're just going to start a new list. Okay, good. So we're going to append to map in both directions. So I'm going to go from S to T, and then we want to go from T to S. And I don't see any self loops we have to worry about. Okay. Okay. So now we can count the number of maps in the number of paths in a recursive fashion. So we have to keep track of which small nodes we've already been in. And so we need a way to tell cave. So we need to tell whether cave's big or small. So now I think, I mean, we could just hard code that because we have few enough examples, but let's actually try using FStar's character library. Okay, so we need to look at the first character, and to do that, we need to know if it's a empty string or not. And I haven't been specifying that the strings are non-empty. So we'll just work around that by saying if the length of the string is 0, then sure, it's a big cave. Doesn't matter. All right. Otherwise, let we don't have that. All right. I'm so spoiled by the Emacs Go mode. I can just add a module, and if it's one I've used before, it'll look it up and oops, add the right import statement. FStar mode is not that smart. Okay. So we don't actually need to qualify these anymore. Okay. Equals char code of the first character, and I don't think we have I don't think we imported that either. No. Oh no, that's the type. So we want U32 of char. Okay. So where's our ASCII chart? So capital letters are between 65 and 90. Is there an easier way to do that? I don't think we can. I don't think we can compare characters directly, but maybe we can. Let's try. Let's try it out. Um, so that would be char greater than or equal to capital A and char less than or equal to capital C. Yeah, the comparison operator is only for ints. All right, but what we can do is uh, A is a char code, and it's the char code for A. We can't use capital letter A. That's restricted use. So all right. So C greater than or equal to CCA and C. Wow, can't we compare them? Well, that sucks. I'll make this bigger. I mean, it's U32T. Don't they have comparisons? Okay, there it is. All right, U32 U int. All right, so all right. Not ideal, but fine. That took much longer than is really required. Okay. And we'll just say all right. So where were we? We were going to brute force our way through the caves, the system of caves, remembering which little caves we already visited. So let's. Okay. So we got our map, and I'm already regretting not giving this a name, so let's fix that. Let's call it an adjacency map. It's a map of adjacency lists. We can say, yeah, type is what we need. So replace that with. All right, much nicer. Okay, so we've got our adjacency map, and we've got. Hello. We've got where we currently are, and we're always going to end, right? As between, yeah, start and end. All right, and then we need a set of small nodes caves that we have visited. So we can define that using a refinement type. Let's see. So this is going to be a set of strings, and every one of them is going to be little. Okay. This is day 12. So not quite halfway through. All right. Is that everything we need? Let's try it and find out. So if cur is end, then that is one path. Right, we got to the end, then we don't want to recurse any further. Yeah, so, well, they're giving us a maze, and they're asking us to count the number of paths that go from start to end, and visit the caves, the nodes with small letters at most once. So, and I didn't think of any clever graph theoretic way of doing this. So, okay. Okay, so we got two options. Is we could check whether we've previously visited something before we visit it or after we visit it. Let's do it. Let's do it. Let's do it here rather than in every. I think this will be a little nicer. So if cur is a member of I hope that doesn't give us problems, but 0. We can't visit it again. Okay. I'll select neighbors equals, let's look up, select current from the map. And so we want to call count paths with each of those being the current path and adding the ones that are small to the neighbors. So let's write a function to do that. Okay. In fact, so okay, let's make it work so that it'll work well with the fold function. So we're given the sum so far and our neighbor, and we'll deal with it. Okay. So if is if it's a little cave, then we're gonna return the total plus count paths, same map, n, and set. The only way to add something to set is by taking a union, so singleton of n with visited. Okay. And otherwise, okay, so we could refactor this addition outside the if statement. Let's do that just to be cute. All right, we want to do the same thing except that we don't update the set. All right, and so we're going to return the sum by fold. I'm doing this backwards. Oh no, this is right. We're allowed to visit the big caves as often as we want. We can't visit the little caves. All right. I am not familiar with usage of Vim. I can save a file in Vim and exit. That's the limit of my Vim knowledge. So I think we're gonna have to use one of the different effects here, because the fact that this function will terminate depends on the input they give us, right? They could give us something with a cycle, and we just continue forever. So I think we need to make this thank you. I think we need to make this divergent. So let's see if where that is meant. Okay, it's big D cap small v. All right, So, list, which means we can't use the total version. Huh, we may not be able to do this at all. We might have to go all the way up to ML or all, which seems unfortunate. Yeah, since this... Hello. Startled again by the follower notification noise. I didn't find how to set that to something else. So I'm gonna just copy my old. I'm gonna copy this into a version that takes. All right, now so we can use that version. So fstar doesn't have effect polymorphism. You can't write a function that works for different sorts of effects. The standard libraries are scattered with, well, here's the version that works on total functions, and here's the version that works on non-total functions. So, all right. So, did I get the wrong way around? Fold left? No. Fold left has the first value on the neighbors. Okay, what's it complaining about here? I missed the then statement. Okay, we called it M. Oh, we got it backwards. Go. Okay, we need to put the type on that function too. Oh, and we did this in the wrong order. Okay, so we visit neighbor 0 neighbors. Okay, why does it think we've still got? Oh, because we called list fold left instead of our fold left. Okay, yeah, so the thing I was worried about is we specified that the set has only little lowercase strings in it. And so it says you're trying to use this with a string that might still be capital, which is kind of silly because it's a string. It won't, if it's all capitals, it just won't be in the set. But the definition set doesn't allow for that. Okay, so all right, there we go. So are we done? Do we just have to run it? I think so. I mean, we might want to switch the ML effect anyway, just so we could print out the paths as we're creating them, but looks good to me. All right, so let's get in IO and our friend printf. Okay, so all right, so given the input, we will parse it into the map. Where did I put that function? Oh, okay. Okay, and then we're going to count the paths with M starting at start and an empty set. All right, let's what? Oh, it's period stuck in there. What is the hotkey there? It is C, Control C, Control R. Oh, phooey. We didn't have the ML effect loaded. All right. So let's look at the examples first. So first is example 1. See what happens. Oh. So our designers gave us a nice new ASCII art Akita that I put on my front page. Well, 1 is not the correct answer. Definitely not. So we should be adding them all together. I don't think there's a value other than 0 I should be using here. So I mean, at least we're getting 1, not 0, but what are we What am I doing wrong here? Okay, there's the problem. Is I changed my mind how I was going to do this, but I didn't do it right. Okay, so we need to update this. Okay. New visited. This is annoying. Maybe it was the wrong way to do it. All right. We can make this work. All right. So the problem was I was putting the cave into the set and then immediately checking it and say, oh, we visited this already. So we need to update before. We need to update the set as we're visiting it rather than before it. So we'll update current else visited. Okay. And then this becomes simpler. Okay, so the first time we visit a cave, we go a little cave, we say, oh, it's not in the set. We're going to add it to the set for all the descendants of this function. And then the next time we visited, that first check will run. Okay. Let's try that. All right, 10 and 19. 10, 19. All right, let's try it on the real input. So I think I've never explained why I have to do these to actually get it to do something. And that's because the only top level statements in F star are creation of a variable or function, or creation of a type, or creation of an effect. There may be one or two others I don't know, like defining an overloaded operator. So the only way to get something done is call it and assign it to a variable. And the underscore just means I don't care what the variable name is. I'm not actually going to use it. All right. So are we correct? We are. Okay, so now we have to might have time to visit a single small. A single small cave can be visited at most twice, and the remaining small caves only once. Okay, so there's a single exception to the rule that is allowed. Oh, did I miss an example? I did. I could have been using this one. All right. So let's preserve our part one. Open up part two. All right, this should be, I think, fairly straightforward. Let's just add a yeah. So that will keep track of, have we visited a on our path, have we visited a little cave twice? All right. So if it's a little cave, let me fix this before I forget again. All right, if it's a little cave and there's already some small cave we visited twice, that's our end. Current end is still the end, they said in the description. All right. So let new visited 2. Okay, so if all right, so if it's a little cave and we visited it before, then it should be the case that um, it should be the case that visited to is still none. So let's assert that, and the type chart, the fstar will tell us if that's true. So in that case, we want it to be some I don't think we actually need to store which it is, because we don't actually care, but we'll leave it alone. We still update the set. Okay, so new visit 2. All right, I think that's all. Let's double check. So it's a little set, and we visited any set twice already. Am I interpreting that correctly? Oops. Okay. We need to check that we cannot visit. We can't visit start twice. We need to include that in here somewhere. So okay, so that takes care of that. We shouldn't really have to do this, but it does know that this string literal obeys our property. We could do something about that by creating a variable that has it, but we're good. Okay. So the first time through, start will not be in the visited set, and then subsequently it will. So we won't always get 0, hopefully. All right. So if it is in our set, but we haven't picked a small cave to visit twice, we do that. Yep. Okay. I think I'm understanding that correctly. And always add it to the visited cave. If it's already there, to the visited set, if it's already there, that's fine. Visited. All right, what does F star think of all this? Okay. So it checked that assertion already. That's not a runtime assertion. That's a compile time assertion. All right, and we need to start this with none. Oops. All right, what does it say? So now we have 36 and 103, and I didn't include that example, but let's see if our number is correct. It is. Hurrah! How'd we do? Wow. I don't know if there's just not many people competing today or what, but my best showing yet this year. Um. All right. Uh, I'm thinking about what could we do to prove the correctness of our count here. Could we say something about this? Um, so one thing is we didn't keep a list of where we'd been, and that might be necessary in order to help us prove that, um, you know, that we're not actually visiting something twice. What else could we do? What properties does this function have? It seems tricky. So for example, maybe we can prove that the count is always smaller if we add things to the visited set. Not strictly smaller though. So could we even show that is the case? So it's a lemma. Okay. So for the Same. This might be easier to prove for part one. So let's just take that as fixed. All right. So what I'm going to do is phrase it as a lemma about two different sets. So X and Y. And so our assertion is count paths. All right, now if X is a subset of Y, double equal arrow, then count paths M X 2 is less than or equal to paths M cur Y visited 2. Right, so if the visited set has more, then we should be all right. So that seems like it's true. Although we might have equality. It could be that there's no path to the extra elements in Y, or they don't exist in the adjacency list at all, or um so the easiest thing would be if we could do induction on the size of the set, that as it gets larger, and if the two sets are equal, then that's true. Then it's trivially true. And if as we make one set smaller, could we appeal to the existing result? I don't think that would work. For one reason, because set doesn't have a cardinality. I think we're going to run into the problem that this is divergent. So, what we could do is say, the value is the sum of the neighbors, just like we described here. And so, if it was true for that, where we increased the size of the visited set, then it would also be true for this one, that either it's 0 because this element is invisited and it wasn't before, or else it's inductively true because we're operating on a larger set here. But like I said, I don't think we can actually do induction on set sizes. So we'd have to do something like do it on lists. All right. Well, we can do things on lists. instead of having those be sets, we could have them be lists and convert them into sets. Does F star know that have anything that helps us out with that? I bet it doesn't. No. There's no properties there. All right. Well, let's just do a warm up on that. So, um, tail implies subset. So if we've got a list A, unfortunately, this might not be strong enough, but let's do it anyway. So our lemma says we better make it a non. Better make it a non-empty list. We could say length is not 0, but cons just says that it's got a head and a tail. All right, our lemma is that as set tail is a subset of the whole list. Tail of L. All right. List. Oh, okay. So we need to qualify our type here, that we can only create lists of types with decidable equality, not any type. All right. So it was able to prove that entirely by itself. So without getting the full subset, so we need a stronger one, which is that if it's a subsequence of L, and we don't have that defined. In fact, we use that as a interview problem at Akita. Don't tell anybody. So it would be nice to prove this, but it seems very challenging. A lot of the pieces are missing. What did I? Oh, okay. I mean, it looks like we're doomed from the start here. We can't even define this because count paths has the effect div, and so we can't use it to define a property. So the type of a lemma is actually just a function of type ghost total. And so the properties we define all have to be ghost or total as well. Okay, so I'll just leave a note. So we were doomed from the start. Uh, so the way we could fix this is prove that our function always terminates. And that seems, like I said, difficult because that's input dependent. So what we could do is put some upper bound on the length of the path and count down from there and terminate if we ever got there. So let's do that one. I don't think I'm going to do the proof, but let's do the total version of this. So this becomes a total function. Uh, max length. Oh, count paths. Alright, why does it still think we have type div? Oh, because we used our div version of fold left. Okay, so that is a total version, and as long as we made max length big enough, we would still get the same answer. So that's the sort of thing we can do to convert a divergent function into a total one. Just make it always terminate after some determinable length of time. So this is a version we could actually prove something about. But I'm gonna call it a night. Thanks for staying up with me, and I will be traveling tomorrow, but I expect to do the live stream all next week. But it may have a late start because I'll be on Pacific time instead of Central time. So come back later for more Advent of Code in F star, more attempts at proving things and wrestling with the type checker. Thanks again to all the people running and sponsoring Advent of Code, including my employer, Akita Software. Check out our jobs page on the live stream link. Good night.